Good morning, ladies and gentlemen. We're going to continue our work with logarithms. So we're going to do some more practice from converting from exponent form to log form. And then we're going to use inverse functions. So that I will explain as we go along. All right. Remember from your work yesterday that log form is going to be written as the log base b of x equals y, or it could be the natural log of x is equal to y. I can convert those to exponent form by doing b to the y is equal to x. Remember, the base is e, even though it's not written. E to the y is equal to x. And so that's what we learned yesterday. Okay? All right, so now let's just do a bunch of different examples. So yesterday I showed you how to go from log form to exponent form. Today we're going to go the opposite direction. We're going to go from exponent form to log form. All right, so I'm just going to do several examples. So the first example, I'm going to start with 6 squared is equal to 36, and I want to go to log form. Okay, so I'm going to put my little title up here. This is exponent form, and then over here I'll do my log form. Okay, all right, because that's what we're going to do on all of our examples. So this is my base, so I would write the log base 6 of 36 equals 2. Notice that when I convert from exponent form to log form, it always puts the exponent in the solution spot, which is how I solve for logs, or solve for the variable when it's in the up position. Okay. The second one, what if I had 4 to the third is equal to 64? This is my base, this is my exponent, so I would say the log base 4 of 64 equals 3. The third one, 5 to the x is equal to 125. So notice that my variable is up, and the only way that I can solve is by using my logs and exponents. So I'm going to go back to log form. The log base 5 of 125 is equal to x. Okay? So now I've isolated my x, and I can actually solve for x. You can't yet, but we will soon. If I had 10 to the third is equal to 1,000, I would rewrite that in log form as the log base 10 of 1,000 is 3. But we usually don't write base 10 because it's a common log, so I would write that as the log of 1,000 is equal to 3. Okay, so that was fairly straightforward. That was nice. Okay. All right, so the next little topic is to go back and talk about inverses. So the log functions and the exponent functions are inverses of each other. Okay? And if you'll remember from the work that we did a chapter or so ago, I can show that these are inverses of each other. So if I did the composition f of g of x and I got an x, and I did g of f of x and I got an x, then I could show that two functions are actually inverses of each other. Okay, so that's what happens with logarithms and exponential functions. So if I had f of x is equal to b to the x, and I had g of x is equal to the log base b of x, if I did the compositions, I would find an x. Okay, and I'm actually not going to show that to you just because I think it might make things a little bit confusing until we've done a little bit more math. All right, so now let me do some examples that illustrate this. Okay. All right, so here's our first example. It says to simplify. Alrighty, so I'm going to have 10 raised to the log of 4, and then because I'm simplifying, I'm going to add an x. Okay. All right, so to do this, it looks weird, but I'm going to go back to exponent form. This is my base. or sorry, I'm going to go to log form. I said the wrong words. So I'm going to write the log base 10 of x is equal to the log of 4. Okay, so I said the log base 10 of x equals the log of 4. Well, notice this is a common log, so it actually still has a base of 10, even though it wasn't written. Okay, and if you'll also notice, everything is the same now. So now I can solve that little baby equation, and I get x is equal to 4. Okay, so that's kind of cool. All right, so if I have another one, again, we're going to say simplify, and I'm going to have the log base 5 of 25 to the x. Okay, alrighty, and I'm going to add another variable in here to solve, because I don't want to mix my x's up, so that would be weird, so I'm going to call it a y instead of x. So I would go back to exponent form, so I would say 5 to the y is equal to 25 to the x. The bases need to be the same to solve the baby equation at the top, so I would get 5 to the y is equal to 5 squared to the x, which becomes 5 to the 2x, because a power to a power is multiply. Now I can solve the baby equation at the top, and I get y is equal to 2x. So logarithms are actually really kind of fun to solve. Okay? All right. So now what I'm going to do is show you an example of the inverse. Okay? So I want you to find the inverse, and you're going to be given y is equal to 6 to the x. So if you'll remember, when I'm trying to find an inverse, I flip-flop my x and y and solve for y. So I'm going to just write this right here, f to the negative 1 of x, and that's going to be where I do my work. So I'm going to get x is equal to 6 to the y. So I flip-flopped my x and y. Now I'm going to solve for y. This is a 6, by the way, not a b. So now all I can do, since my variable is up, is go back to log form, because this is exponent form, so I'm going to go to log form. So I would say the log base 6 of x equals y, because remember our task when we are finding the inverse is to solve for y. Well, we just solved for y by going back to the other form, and I'm going to write that the inverse is equal to the log base 6 of x. So that was actually kind of cool. All right. All right, so I'm going to just do a couple more examples of finding the inverse. Alrighty. Okay, so in the next one, I'm going to be given y is equal to the natural log of x plus 3. And I want to find the inverse. Remember, even though it's not written, the base is e. So I'm going to flip-flop my x and y, solve for y. So when I get ready to do my work, I'm going to flip-flop, so I'm going to get x is equal to the natural log, and I'm just going to write the base there so you can see it, of y plus 3. I need to solve for y. So the only way that I can do that is to go back to exponent form, because this is in log form. So I'm going to go back to exponent form, so I'm going to say e to the x is equal to y plus 3. I'm still trying to solve for y. So now I'm going to say y is equal to e to the x minus 3. So that tells me that the inverse is e to the x minus 3. Okay? And that would be my inverse. So I can go back and forth by switching between the two forms. Let me just do a couple more examples. Okay? Again, I'm still trying to find the inverse just so you can get comfortable with this process of switching between the two forms. All right, this one is going to be y is equal to the natural log of x minus 5. So when I do my work to find the inverse, I'm going to flip-flop. So I'm going to get x is equal to the natural log. I'm going to write the base e of y minus 5. It's in log form, so I'm going to go back to exponent form. E to the x is equal to y minus 5. Y is going to equal e to the x plus 5, and this is my inverse. Okay, so it's actually kind of cool. Alrighty, one more example like this. Okay. Again, we're still finding inverses so that we really understand that logs and exponents are the opposite of each other. You're going to be given y is equal to 4 to the x. Now it's in exponent form, so I'm going to do my work for the inverse. So I'm going to flip-flop x is equal to 4 to the y. I need to solve for y. It's in the exponent position, so I'm going to go back to log form. So I'm going to say the log base 4 of x equals y. That was pretty easy. My inverse is the log base 4 of x. Okay? Alrighty. So the only other thing that I have to show you that's new for today is what the graph of logs looks like, because they are a little bit unique. Okay? Alrighty. So the graph of y is equal to the log base b of x is going to look like this. Okay? It has a vertical asymptote, and we've talked a little bit about these, but we're just going to keep talking about them. In Chapter 8, we'll get a lot of information about our asymptotes. It has one at x is equal to 0, which is a vertical line at the y-axis. So the graph is going to go like this. Okay? It crosses the x-axis at 1, 0. It will never cross the y-axis. And the unique thing about the graph of the logarithm is everything to the left of the x or the y-axis is undefined. You cannot take the log of a negative number. Okay? Same thing is true for the natural log of x. Okay? If I put that in my handy dandy grapher and graphed it, I would have basically the same graph crossing at 1, 0. Everything over here is undefined because I can't take the log of a negative number, and I have a vertical asymptote at x is equal to 0. That means that this graph is trying to get really, really close to this line, but it's never going to quite get there. Alright, so those are the graphs of the two functions. Okay, you cannot take the log of a negative number, and the reason is that the graph is undefined to the left of the y-axis. Alright, let me give you your problems. Okay, love logs, so much fun. So the first set says convert from exponent form to log form. Okay. Number 1 is 3 to the 4th is equal to 81. Number 2, 5 to the negative 2 is equal to 1 over 25. And then number 3, 4 to the 3rd is equal to 64. Sorry. Alright, then the next set says find the inverse, show all work. We always want to make sure that we show our work. So number 4, you're going to have y is equal to 7 to the x. Number 5, you're going to have y is equal to 2 to the x minus 3. Okay? Remember, flip-flop x and y, solve for y. All right, good luck with these, and I will see you tomorrow.